Imagine standing on a warm summer evening in Hawaii in 1962. The night sky is clear. Then suddenly, a blinding flash of light, brighter than anything you've ever seen. A shimmering display of red, green, and white sweeps across the heavens. People gasp. Some cry. Others pray. Many believe the world is ending. But this was no natural phenomenon. It was a nuclear explosion, one unlike any before it. On July 9, 1962, the United States detonated a thermonuclear warhead 250 miles above the Earth's surface, in the emptiness of space. The test was called Starfish Prime, and it remains one of the most ambitious, mysterious, and dangerous nuclear experiments ever conducted. It lit up the night sky, disabled satellites, knocked out power in Hawaii, and created a radiation belt around the Earth that lasted for years. But to understand why we nuked space, we have to go back to the shadowy dawn of the Cold War. The Cold War heats up. The 1950s and early 1960s were a time of deep tension. The Cold War between the United States and the Soviet Union wasn't just political, it was technological, ideological, and militaristic. Both nations raced to outdo each other in everything from rocket science to nuclear weapons. By the late 1950s, both superpowers had successfully detonated hydrogen bombs, far more powerful than the atomic bombs dropped on Hiroshima and Nagasaki. The arms race was in full swing, and each side feared the other would develop a devastating new capability first. At the same time, both nations had begun exploring space. Sputnik, launched by the Soviets in 1957, was a wake-up call for the United States. America quickly responded with its own satellites, rocket programs, and ultimately NASA. But while scientists dreamed of peaceful exploration, military planners were asking darker questions. Could a nuclear weapon be used in space? Could it disable enemy satellites? Could it knock out incoming missiles? Could it blind radar or create electromagnetic shields? The only way to find out was to test it. Early high-altitude nuclear tests. Before Starfish Prime, the U.S. had already begun experimenting with high-altitude nuclear detonations. These weren't like the ground-level tests in Nevada or underwater tests in the Pacific. These were missiles carrying warheads to the edge of space. In 1958, a series of tests under Operation Hardtack Y explored the effects of such explosions. One of the first, Teak, detonated at 43 miles above Johnston Island. The resulting flash blinded observers and disrupted radio signals for hundreds of miles. Another test, Orange, produced similar effects. Around the same time, the Soviet Union was conducting its own high-altitude experiments. The K project included the K3 detonation, which created massive electromagnetic pulses, or EMPs, disrupting electrical systems and knocking out power grids across Kazakhstan. Scientists had stumbled onto something powerful and dangerous. In 1958, the U.S. conducted Operation Argus in the South Atlantic, detonating lower-yield bombs at altitudes of around 300 miles. These tests confirmed a bold theory, that a nuclear explosion could create artificial radiation belts by injecting charged particles into Earth's magnetosphere. These early tests paved the way for something bigger, much bigger. Planning Starfish Prime. By 1962, the United States had developed the technology and confidence to carry out a truly ambitious high-altitude nuclear test. The plan was to detonate a large thermonuclear warhead far above the Earth, outside the atmosphere, in the lower reaches of space. The chosen site was Johnston Atoll, a remote island in the Pacific Ocean. From there, a Thor missile would carry a 1.4 megaton warhead into the sky, about the same yield as 70 Hiroshima bombs. The target altitude, 250 miles, roughly the same as the orbit of the modern International Space Station. The test was called Starfish Prime, and it was part of a larger series known as Operation Fishbowl. What they expected was a brilliant flash and some interesting data. What they got was something else entirely. July 9, 1962. Detonation. At 11 p.m. Hawaii time, on July 9, 1962, the Thor missile roared off its launch pad from Johnston Island. The warhead reached its target altitude and detonated. The explosion was visible for more than 1,000 miles. In Hawaii, skywatchers saw a flash so intense that it temporarily blinded some. Moments later, artificial auroras rippled across the sky. Red, green, blue, and white waves that danced for minutes. It looked like a fireworks show from another world. But the effects were not just visual. An electromagnetic pulse, an EMP, raced through the upper atmosphere, reaching Hawaii in less than a second. It knocked out streetlights, set off burglar alarms, and disabled telecommunication systems across the islands, 900 miles away. The power of the EMP shocked even the scientists who planned the test. But the consequences didn't. The artificial radiation belt. One of the most unexpected outcomes of Starfish Prime was the creation of an artificial radiation belt. The explosion released gamma rays, neutrons, and high-energy electrons into space. These particles became trapped by Earth's magnetic field, creating a new band of radiation that encircled the planet, just above the natural Van Allen radiation belts. This man-made belt extended from roughly 1,000 to 1,500 kilometers above the Earth. And it was deadly. Within weeks, 6 satellites were damaged or destroyed. This included the iconic Telstar 1, the world's first active communications satellite. It had just launched the day before Starfish Prime. Radiation crippled its systems and shortened its mission. Another satellite, Ariel 1, co-launched by the US and UK, was also severely impacted. These failures raised alarm bells. The very infrastructure that was supposed to represent the future, space-based communication, was now vulnerable to human-induced radiation. The artificial radiation belt persisted for months, and in some regions, even years, gradually decaying and merging back into the natural belts. The scientific discoveries. Ironically, despite the chaos, Starfish Prime provided scientists with unprecedented data. They learned how high-energy particles behave in space. They saw firsthand how the Earth's magnetic field traps and distributes radiation. The test deepened our understanding of the Van Allen belts, electromagnetic pulses, and atmospheric interactions. It also made one thing clear. Space was not immune to the consequences of human warfare. Global fallout. Political and environmental. The reaction to Starfish Prime wasn't limited to satellites and sensors. Around the world, scientists, politicians, and military leaders realized that testing nuclear weapons in space carried profound risks. Not only could it disable technology and threaten astronauts, but it could also have planetary consequences. Public concern was growing. Protests against nuclear testing had already begun, and the radioactive fallout from earlier ground-level tests had caused global alarm. Starfish Prime, along with similar Soviet experiments, became the final straw. In 1963, just 1 year later, the United States, Soviet Union, and United Kingdom signed the Limited Test Ban Treaty. It banned nuclear weapons testing in the atmosphere, underwater, and in space. Tests were now restricted to underground sites only. Starfish Prime had lit the fuse. But diplomacy, at least for a time, snuffed it out. Legacy and lessons. Today, Starfish Prime is both a cautionary tale and a scientific landmark. It proved that nuclear explosions in space could generate EMPs strong enough to cripple electrical grids and destroy satellites. It showed that human activity could alter the Earth's magnetosphere in ways we barely understood. And it demonstrated the need for restraint, because the next experiment might not have such a contained outcome. In an era where new space races are underway, where satellites monitor our every move, and private companies dream of colonizing other worlds, the lessons of Starfish Prime remain more relevant than ever. Nuking space is not just a bad idea, it's a catastrophic one. On that night in 1962, humanity briefly turned the heavens into a battlefield. The stars disappeared behind a blinding flash. The sky shimmered with radiation. Satellites died. Lights went out. And the world held its breath. Starfish Prime was a moment when science, ambition, and fear collided. When we looked up and realized that even the cosmos isn't safe from ourselves. Let it be a reminder. We can reach for the stars. But we must do so wisely. If you found this video intriguing, Don't forget to like and share it with others who love mysteries of history. Hit subscribe and turn on the notification bell so you never miss our next deep dive. Thanks for watching.